Hey everybody, it's Technic Builder. I wanted to show you all me modifying a battery pack. Again, because I want to run 8 cells, not 6, because rechargeable batteries have lower voltage, blah blah blah. So, what I've done is taken a battery pack, take out the screw here and here. This slides out with a little bit of force. And then what I did is there are metal things, the things that create the circuit of the battery pack. I pulled those off. I pulled the wires out. It doesn't matter if these stay here or not because we're going to solder new wires on anyway. But the next step is to cut this in half, which I know makes a lot of you cringe. Basically what we're trying to do is we put these two pieces back together and then we just cut it off. So I save the electronics. Basically, I save the power LED, the LEGO proprietary connector, and the on-off switch. So if I'm running 8 cells up to about 10-ish volts, and then I take, or if I then shunt the resettable fuse, a battery pack should, in theory, give us as many amps as we want. There's the resettable fuse right there, and I plan on soldering that off. I finally have a replacement soldering iron because my cat chewed through one. But if we take that off, then we should be able to get as many amps as we want. Although really the run time of these batteries drops off substantially if you pull more than about 6 amps out of them continuously. Plus I really don't know if all this circuitry can handle that many amps. So I'd probably still only run like 2 XL motors or 1 buggy motor off of each battery pack. But anyway, I don't know why I'm making a video of me destroying Lego because it makes a lot of people cringe. But I'm just going to show you how I'm modifying these. So we're going to put that back together. It really doesn't matter that that piece of wire is poking out at all. I'm going to take this, put it in my not very good vise. I used to have a much better working area. Well, I don't really have a good working area anymore, so we're going to get plastic shavings all over my table. But this is a 32 teeth per inch hacksaw blade, and it's rated for metal, but I find it much better for cutting plastic than this old thing that I was using that's maybe 16 teeth per inch. I don't really know. But the finer the teeth are, the better it seems to go through the plastic. So as I start cutting this, I have to start with a little bit of an angle. If I go straight down, I will end up doing this instead. Whoops, I basically almost shaved off the backside of the PCB, but I got lucky and that still works. But I don't want to do that, so I'm going to start at an angle. And as soon as I get in there, I'm going to turn it more vertically. And this is the fast part. And then we go through the other side. And I'm going to cut through that wire that you saw earlier, but again, it doesn't matter because we're going to solder those off anyway. Alright, well, so that's not too hard. It makes shavings everywhere. I gotta vacuum thoroughly. Plus I don't like the idea that I can smell the plastic, but I probably won't die. So that's what you're left with. Well, I'll clean that up. You don't need to see me do that. But my plan is to take these and here we go. Solder wires on from these 8 cell packs. And then just glue this in some way. I'll tuck the wires in there. So that there's my pack. So I retain the proprietary LEGO connector. I keep my switch. I keep my power LED. I keep the ability to reverse polarity, which is very nice. And then basically the goal is just to see how many amps this circuitry can handle. Everything LEGO seems to be a bit over-engineered. It's probably fine at 5 amps, but we'll see. But I hope you enjoyed that. I will be making a video of modifying an XL motor. Somebody specifically requested it. I'll do it. I don't know, I'm being lazy. Okay, bye.